We got some puffy Cheetos right here. Do you guys think that this Cheeto would be better in liquid nitrogen? Perhaps, maybe, yeah. If you're saying yes, I don't know if you're concerned for my safety or not, but you know what? We're going to go for it anyway. We're just going to see what happens. I actually get a brain freeze at ice cream, so we'll see how good of an idea this is, but I'm doing it. I'm going for it. Okay. So I'm going to put a little piece of Cheeto inside there. It is getting nice and cold. Remember, our liquid nitrogen is negative 321 degrees Fahrenheit. It is so cold, and I'm about to eat that as well. So wish me luck, and don't laugh. Try not to laugh at me. I'm going to put down my mask for just a moment. We're going to see what happens. Okay, here we go. In 3, 2, 1, going for it. Woo! Okay, first of all, that was extremely cold. That was freezing. But second of all, you probably noticed something happening. You probably noticed that there was fog coming out of my mouth and my nose, right? Kind of looked like a dragon, right? Now, have you seen that before? Maybe when you go outside on a really cold day and you're like, you might see your breath. The reason for that is because there's a massive temperature difference. So that outside temperature is going to be very, very cold, of course. It's going to be like a couple of weeks ago, could be even 0 degrees Fahrenheit. And then our mouths are about 98.6 degrees Fahrenheit. That's about our body temperature. So super cold. That massive temperature difference is actually going to create that condensation, that fog, that water vapor that we can see, which is really, really cool. But you know what? I might have another little piece. We can actually see it, because let me try this with my mask on as well. What would happen? We can kind of see how germs potentially would go all over the place as well. Okay, so here we go. We're going to try it. What is going to happen with my mask on? I'm not going to lie. This is the first time I'm trying this as well. Here we go. And okay, that was really foggy for my eyes. I couldn't see there for a second. But of course, that's why during this time, masks are very important. It's going to protect us overall. Now, that was really neat. Unfortunately, I do need to say goodbye to our liquid nitrogen, because we have a lot of other cool things to show you. So goodbye, liquid nitrogen. It's going to go over here to the side. Now, who has ever wanted, or who has ever taken a bath? Hopefully we have a lot of hand raisers, right? If we got hygiene going on, yes, perhaps. Now, of course, if you've taken a bath, I want you to show me with your finger. What does your bath water do when you're draining it? So show me with your finger. What does it do near the drain? Hopefully you're thinking about this motion, right? Now, that motion is something you might be familiar with calling a tornado, right? So tornadoes definitely in the weather, they're scary. They're this rotating force around a center point. But in the science world, we actually call that a vortex. So a vortex is going to be any fluid that's going to be going around a center point. I'm going to see if we can recreate that with a couple things over here. I've got a couple of 2-liter bottles as well as a connector. We also have just some water with a little bit of food coloring to add a little bit of pizzazz. But this is totally something you can do at home. You don't even need a connector. You can use something like duct tape to create this. But I want to see if we can recreate that vortex in the liquid form with water. So let's see if I flip it over. Yes. Is it happening? Is there a vortex being created? No. Okay, this is a little anticlimactic. Okay, you know what? Let's try again. Let's see what happens this time. I'm going to put my hand up top and spin it around and see if we can actually create that vortex. Yes, we are making it happen right now. That liquid is going around that center point, and it is draining the water to the other side over here. Now, this is also the quickest way to get your water to drain. So just know when you're draining your bathtub next time and you see that whirlpool, you see that vortex, that liquid tornado, that is actually the fastest way to drain your water, because it goes so much slower with those bubbles just coming up a little bit at a time. And again, this is something that you guys can do at home as well. Now, that was cool and all, but I wonder if we can even do it in a bigger way. I want to try it out. I've got its big brother right over here. Oh, it's a little heavy and I'm super weak. Look at that. We have a lot more water over here. And I want to see if we can flip this one upside down and maybe create a giant liquid vortex. Hopefully we can do it. Wish me luck. Okay. And try not to laugh at me as I struggle. Okay, here we go. We're struggling, but almost there. Yes. Yes. We got it. Okay. So far, nothing's really happening. Those bubbles are slowly going up. It is draining very slowly. But remember, maybe if we move it around a little bit up top in a circular motion, we can create that vortex. Let's try it out. Oh, those bubbles are actually coming a little bit faster now. And we did it. We created a giant liquid vortex. Look at how much faster that water is draining now. That is insane. All of that water is able to drain so quickly with the help of that liquid vortex. And these are, of course, several gallons of water as well. And just in a little bit more time than those last couple bottles, we can see that all of that water has drained. How neat is that? Okay, I'm going to set it down to the side because I want to create that vortex in a different way. Over here, we've got a trash can. You're going to find that we love trash cans here at the museum, and we don't necessarily use them for throwing things away. As you can see, this one's a little unique. We actually have a little disc here at the bottom that can make it rotate. This is a lazy Susan is what it's called, and we can spin it round and round. So we know that the air is in fact going around and round. But we cannot see that air. But what if we could? I'm going to try to do just that by actually adding some fuel. I'm going to add some fuel, and then I'm going to add some heat in the form of a flame. Okay, so I'm going to put my safety glasses back on. And we're going to see what happens if I can get my cap off here. I think I put it down pretty tight. Yes, we got it. We're going to put that fuel down. This is isopropyl alcohol, in which I'm using. We're going to have that flame down at the bottom there. Perfect. Okay, so we have our flame here, but nothing's happening yet. What if we try spinning it? Let's try it out. Wow, yes. We have created what looks like a fire tornado, or of course, the scientific word, a fire vortex. This one's like almost 3 feet high here in our studio. Wow. Okay, let's see if we can make it go the other way. Now, these actually happen in real life as well. In the past year, California has had a lot of wildfires. And when the wind goes in a certain direction just right, it creates the perfect opportunity to create a fire vortex. And some of these have been measured as high as 2 miles. That would be terrifying to see a 2-mile high fire tornado coming towards you. But fortunately, we can see it right here from your computer screens with the help of our fire tornado. How fun is that? There's a little bit left. I don't think it's going to create anything. Oh, and it's all gone. But like I said, we did that all with a trash can in a really fun, cool, and safe way. But is it ever okay to play with fire at home? No, it is extremely dangerous. We are very well trained here at the museum. So make sure not to try anything that you see. Of course, unless I tell you specifically how you can try it at home. Okay, I'm going to set this down. Remember how I told you that I love trash cans? And we might not use them for the purposes that trash cans are used for. Well, I've got another one. And it is right over here. Hopefully you can see it right here. Yes, fantastic. Now this is a bigger trash can. But the reason why we can't throw anything away is it has this little rubber sole up top. We can beat it like a drum. You can create a nice sick beat. But on the other side, we have a hole. And it's a much smaller hole. Now, the goal with this trash can, I'm going to put this little shoulder strap over me. I'm going to try to take all the air that's in here and push it out of this hole. we're going to see what happens. Maybe we can create an air cannon. So I'm going to come over here. I want to make sure our camera is ready. Awesome. Hopefully you can see me now. Perfect. And we have set up these cups. So with these cups, maybe we can force them off if we truly are able to blow all of the air out of this trash can and maybe make these cups move. Let's try it out. Here we go. In 3, 2, 1. Oh, okay, I missed. Okay, or maybe it worked. It didn't work. Who knows? Okay, here we go again. 3, 2. Oh, here we go. Oh, there we go. Third time's a charm. We can just sweep with all this air with our cups. But we successfully did it. I have terrible aim, as you can see. But this is, in fact, an air cannon. We can't necessarily see that air move. We know, of course, it moved because it knocked the cups off. But what if we could? Well, over here, I actually have a fog machine. I'm going to bring it up here. We're going to add a little bit of this fog juice to our trash can. And maybe when we try this again, we might be able to see that air move in a really cool way. So let's try this again. Let's see what happens. There we go. How neat is that? We are able to create these rings. Who knew that's how the air was actually moving out of this trash can? Now, believe it or not, these rings that you're seeing is another form of a vortex. That's right. If you actually look closely at these rings as they pass by, they are in fact rotating around a center point, just like those vortexes we've been talking about. Now, this donut shape, this Cheerio shape that you're seeing right here, this in the science world, we actually call a toroid. So those toroids, maybe you can actually go to the donut shop soon and you can ask for a toroid with sprinkles on top, see what they say. They might look at you like you're weird, but that's okay. You know, a fancy word for a donut is a toroid now. Now, this is something you can also make at home. And if you have something like a fog machine, you can see these fog rings as well. And this is not just an air cannon we know now. It is a vortex cannon. Now I'm just going to pummel Keesha, the camera woman, and you guys, of course. But of course, if you were here in person, you'd be able to feel that air for yourself. So you can make something like this at home, not even necessarily with a trash can. You can make something with a cardboard box. If you tape up all the sides of that cardboard box, cut a hole at one side, and hit it, that is going to create your vortex cannon, your air cannon. And of course, you can actually see that toroid with the help of a fog machine. Very cool. Now I have one last grand finale demonstration to show you guys. And we need to go back to something that I love, and it is liquid nitrogen. That's right. We have one last grand finale liquid nitrogen demonstration for you guys. So I'm going to come back and get my beaker right over here. Oh, and look what we created. Condensation in the form of snow. Let it snow. Let it snow. How neat is that? There's like snow all over the table right here. I'm sure y'all are like, we're sick of that now. We had it for so long. I don't even need it anymore. But we're going to take the rest of that liquid nitrogen and we're going to put it in this pitcher. So I'm going to set the rest of our liquid nitrogen inside of that pitcher. But because this is, in fact, the grand finale, I think we need a little bit more liquid nitrogen. So I'm going to do just that. Now, on the side table over here, I have boiling hot water. Boiling hot water is going to be measured in the temperature of 212 degrees Fahrenheit. Now, if we mix that with our temperature of our liquid nitrogen, which is negative 321 degrees Fahrenheit, that is about a 500 degree temperature difference. That is massive. So we're going to see what happens when we combine those two temperatures together. So over here, I've got my hot water, that 212 degree temperature water. Perfect. And we're going to put it in our pitcher and see what kind of reaction we have. Now, this might be massive, hopefully. So one more time, form a hypothesis in your head of what you think will happen. And I want you guys to count down in your classroom as well. In 5, 4, 3, 2, 1. Woohoo! We have created a giant cloud volcano over here. It is dripping from the ceiling right now. And we have all of this fog coming out of this picture right now. That is crazy. Do you guys see that? Wow. Now, that massive temperature difference is just like the one we saw with our Cheeto. The temperature difference between my mouth as well as that cold Cheeto was massive, but this was much more massive, about 500-degree temperature difference, which creates that water vapor, that fog, in the form of our fog volcano that we could see. Below it, we can see a lot more of it as well. How neat is that? Now I'm going to actually set it on the table so you can see it just fogging up for a little while until it all evaporates. But that is our awesome science show. I hope you've enjoyed all of our liquid nitrogen and our vortex demonstrations. But I'm sure you guys might have some questions that you might have been thinking of throughout the show. So I want to hand it over to you guys in your classrooms to see if you might have any questions of anything you saw during the show.
Let's start it off with a big round of applause for Kelsi. Wow, that was amazing. That was so cool. So what we would like to do is get you all to raise your hand. You can ask your teacher the question and the teacher can relay that to us. So we want to hear what your thoughts are about our program. So we'll wait for our first question.
I know you might be in awe right now. You're probably just so excited from everything you saw. I just want to see if y'all have any questions. This is your opportunity to ask anything about what you saw during the show.
We have a question. One of the students asked, awesome. How do you make liquid nitrogen?
How do you make liquid nitrogen? That is a great question. Now, we don't necessarily make liquid nitrogen at the Museum of Discovery. They have to do it in lab in different factories and places where they're able to condense nitrogen. Because remember, we talked about it, that it's the nitrogen, the air around us, but in liquid form.